Hi, this is Larry. Today I'd like to talk about foreign keys and referential integrity. These highly go well together, and it's an important topic when you're talking about database design. Now, when we talk about database design, we go through the normalization and entity relationship diagrams, and during those processes, especially during normalization, what you find is that you have your different entities being developed. And when you do that, you're trying to find unique identities, and so you're using keys called a primary key. And the primary key is to help identify unique rows in a table or the unique entities. And because of the normalization process, and you find these different entities, you take out of the first entity, you'll be extracting out attributes to create another entity. But you need to keep them associated with each other. And you do that through a foreign key. And that foreign key is then an attribute, a collection attribute that matches the primary key in another table or is null. So basically in the first table that you would have your attributes, and you would create a second table, and you would have to then be able to associate between that second table, the primary key, with a foreign key in the first one. Let's take a look at this in a normalized database table structure. Here's an example, and this is a very common example of order and placements. You should just kind of memorize this this format here. Basically, here we have an order item, a product, and a customer. Okay, and let's just take a look at order. Order has order num, customer num, order date, and a ship date. Order num is the primary key that uniquely identifies all this data in here. Okay. Now, customer num is the foreign key because there's another entity down here called customer, and that is the customer num is down in here. And if you notice, a requirement for the foreign key is that this description down here, cust num, as an attribute, must be the same up in here. Okay. And what this does is that by having this association, we're able to take from this order, we're able to find out this information specific to this order. In this way, we're reducing a lot of data as far as storage, less repeated data. We're also protecting entity integrity and referential integrity by doing this. And it makes the database run a lot more efficient. Let's give an example of what I mean here. Well, let's look at if we wanted to find the customer name and address for a specific order, in this case, order 5938. Well, we can do this by putting together a select statement. This select statement is going to say, select order num, first name, last name, street name, city, state, and zip. We know order num is with order, but the remainder of this is with customer. So therefore, we have to have from order table and customer, and then we have to say where customer num, order customer number equals customer num. With this, and then we also say order, where the order number is 5938. So what this means, working backwards, we go in, we find order number 538 based on this, and we can find that entity. Then we go to that customer number, and we know what that customer number is in that entity. We go down through and search and find in the customer table, and we find that entity, specific entity, and then we're able to provide this information. So as a result from all that, for that order, we could find this information. Order number 5938, Daffy Duck 546, Waddle Lane, Lake Nippersink, Illinois 68483. Is making sense? And why we need to have foreign keys and their associations with primary keys. There's more to it though. Let's talk about referential integrity. The concept of referential integrity is that it's to provide for that the references between the two are very valid, between two tables are very valid. And this means that the values of attributes that are identified as foreign keys must then match a primary key value in the reference table or be null. Meaning that you can't just go put in numbers, you have to actually have a number that matches. When you put in a foreign key, it must match what's in the reference table, or you can't input it. Okay? So therefore, a foreign key, and keep in mind that is an attribute or collection of attributes that matches the primary key in another table is null. What I'd like you to think about this in the long run is put these two together. Just say to yourself that a foreign key really is an attribute or collection of attributes that must match a primary key value in the reference table or be null. If you don't do that must match, you'll be really greatly sorry you ever did that. You'll have bad data, you'll have things not coming up that's supposed to come up, and you'll not get the data you want to. Therefore, you have to make sure that you're always putting in referential integrity. Okay? The purpose of the primary key then to keep in mind is it's provide for entity integrity, which means unique entity. And the purpose of a foreign key is then to provide for referential integrity, which means a perfect match. If you can keep this in mind, that a purpose of a primary key is to provide for entity integrity, and that it's there to provide for the unique entity, and the purpose of the foreign key is to provide for referential integrity, that means it's a perfect match. You will be doing well as you continue using databases. Let's look at this from design a little bit again here, and I want to talk a little further about how to do all this. We've seen when we do an entity relationship diagram, we can see a simple diagram that shows associations between two people. We're assuming there's probably going to be a foreign key match here. We go into a table description, we actually write out the attributes, and we're able to identify those different foreign keys. But I want to give you a big warning here. Make this a big warning. Even though you do the diagram and you do these tables, it doesn't mean that a foreign key is actually enforcing or matching and making sure that it's working to match. Okay? One of the keys here to make sure of, remember, I believe it's talked about in the Murex server book in reference to it too, is that when you use any tools like Microsoft's database management tools, where you are able to actually create the entity relationship diagrams, those diagrams, if you go implement the tables, may or does not normally implement a actual foreign key. You have to do that manually. Okay? That's why I kind of I kind of withdraw from actually implementing databases that way myself. So warning for that. When you go to use Access, if you've ever used Access in the past, you can do the same thing in Access. It's basically the same tool. You go out there and draw your little diagrams and say, okay, and match these two tables up by then and draw the lines actually to the attributes. But you actually have to go to another step to enforce referential integrity. I have seen so many bad databases because of that. People are getting erroneous results because of that. And a lot of times they don't even know that's happening, that they're doing things wrong. So what do you do to correct that? Well, when you go to create a table, tables, you need to start with the first initial tables and create the primary keys. In this case, an example with the order and customer, we would have customer table created first, and this is a table description that would create that table inside there. Notice it says customer num, says not null primary key. Okay. Then you're going to create the order table. And the order table, of course, is going to say order number, not null primary key. But then it's going to also say customer number, and it's going to say foreign key, references customer, and it actually gives the specific attribute that it needs to identify. You need to do this when you create tables. Otherwise, you will fail to actually make foreign keys work. Always remember, just keep in mind that a foreign key, the concept of a foreign key, is for referential integrity. Therefore, you must be thinking in your brain, simply put, that a foreign key must match another key in its referencing table.